Dear students, today we are going to discuss the experiment number 7 and 8, that is simulating a wind turbine, and then by using that turbine, whatever may be the power generated from that one, we are going to convert into the electrical energy by using a generator in experiment number 8. Okay, so before directly going to that one, we'll try to understand how actually we are trying to emulate the wind turbine. Okay, so here we have used, see, generally a prime mover has to be there for a generator. So in conventional sources, we are going to use a turbine connected to the shaft of the generator via some gear system. And whenever wind is going to flow, then it is going to hit the blades, and in turn the blades will try to rotate, and the shaft is going to rotate. And depending upon the in case if you want a fixed speed application or fixed speed, then we are going to connect it to a gearbox. Okay, the shaft is will go to a gearbox, and through that gearbox we'll be getting a constant speed. However, in practical it is difficult to get, but this is a system. Okay, this part now we try to emulate in a simulation. Okay, so here how to do this one? We are going to take a separately excited DC motor. Okay, we are going to take a separately excited DC motor. In separately excited DC motor, we are going to give a supply to the field. Here you can check here. Here where this is a field and this is a motor. So we are going to give a separate supply to the field and a separate field to the armature. Right? Okay, but my speed should be variable one. Okay, if I give directly a 220 volt supply, then it will rotate constantly. Now I want to get a variable voltage. Okay, so how we can able to get? Two ways we can able to get. One is in case if you want less than the base speed. Okay, whatever may be the base speed will be there. Okay, if I want to vary my speed below the base speed, then we can able to do it by armature voltage control method. Okay, no sir, I want to go beyond the base speed, then in such case we are going to change the field winding. We call it as a field weakening region. Okay, fine. So there it will run at beyond the base speed. Currently, we don't want to run this at beyond the base speed. We would like to run it for the base speed only. So we want to below the base speed only. We want to control the speed. Okay, that we can able to achieve by using two ways again. Okay, two converters are there for us. One is a rectifier converter. Another one is buck-boost converter or buck converter. Okay. Since it is here we are trying to operate less than the base speed, so our input voltage is 220, so we want to vary from 0 to 220, so that's why we are going to use a buck converter here. Fine, so we are going to use a buck converter. Okay, so how to achieve all these things? First we will be taking a three-phase AC supply. Okay, this AC supply we are going to use a three-phase rectifier. Okay, that is by using diode converters. Okay, by using diode uncontrolled rectifier actually it is. Okay, so after that one we are going to connect one capacitor across it, and we are going to get a ripple of ripple free or ripple less DC source. That DC source is fixed one. Okay, now we are going to use a buck converter. Okay, by changing the duty ratio of this buck converter, we are going to change the DC voltage, output DC voltage. Okay, Fine. Now for this DC voltage, now field winding is there. For this field winding, we are going to connect one AC supply. Okay, this AC supply again we are going to convert into the DC by using a rectifier, and we are going to connect it to the field. Since currently I don't want to use this, I would like to run only for the less than the base speed. I can make this field winding as fixed voltage. So that's why I have used a single phase rectifier. Okay, that is diode rectifier, uncontrolled rectifier, in fact. Okay, so this will be a fixed voltage. Okay, field winding will be a fixed voltage, and I am going to vary the buck converter, that is output voltage of the buck converter, by changing the duty ratio. Okay, and as I am going to change the voltage, the speed, the input to the DC armature voltage is going to be changed, is going to be vary, and in turn it will change the speed also. Okay, so that is this emulates a wind turbine. This is the basic idea. Okay, so we will try to simulate this one. Okay, this is your experiment number 7. Okay, I will try to take a blank one. Okay, and this is my experiment number 7. Try to take this all these things. So a power GUI is required. Okay, fine. So now here all these things I will remove. Okay, we will try to take a constant tag. Okay, fine. So now we will see each block. Okay, we will try to understand each block. So this is my basic three-phase supply. Here I have taken a star connection. Okay, my phase-to-phase voltage is 450, frequency is 50 Hz. This is my source, and this is a measurement block, and this is a uh, universal bridge. That is, this one is I have taken diodes. Okay, so rectifier, three-phase rectifier, and controlled rectifier, in fact. Okay, and then I have used a capacitor to filter the AC components in the this output, and then this is my buck converter. Okay, this is my buck converter. So basically this is my buck converter. I'm going to change the duty ratio here. Okay, duty ratio here. So here if I click this one, 0.2, say suppose. Okay, we'll check the voltage also. Yeah, okay, this is my buck converter, and now you can choose machine parameters. So you can choose here, a lot of parameters are there, whichever you want you can choose it. Okay, so basically for 300 voltage, 750 rpm, 5 hp I have taken. Okay, apply, and for this, what is the field winding? The field winding is 300 volts. Okay, so I'm giving a 300 volts here. Okay, this is my field, f plus and f minus. Here I'm giving the 300 volts. Okay, fine. Now we'll try to operate it. Okay, we'll take a measurement block. This is our buck input voltage, this is output voltage, and this is a speed. Okay, so this is why. So no need to connect each and every, just press control and click on the icon. Okay, that's it. So now we'll try to run it. Try to run it for 5 seconds. We want the steady state value. Okay, so it is coming around. So 200, 2000 speed. Okay, and input voltage is around 200. Sorry, input is around 490 and the output is around 200 volts. Okay, we'll try to reduce further. This is the maximum we can able to get. Okay, now if I'm going to change the speed 0.5, okay, speed has to change. You can observe speed has changed. So this is how we can able to simulate a turbine. Okay, wind turbine in practical applications. Okay, in practical applications. So since the hardware is currently not working, a prototype in simulation I have tried to prepare. Okay, so this is how actually it is going to work. So if you change the duty ratio, then correspondingly speed is going to change. Okay, however, I have given a unit value 1 here, torque. In fact, whatever may be the load on the machine will be the generator, the same will be reflected here. Okay, so now in this experiment what we have to understand, that is, if you change the duty ratio, then your input voltage is going to change. Okay, input voltage is going to change, sorry, output voltage is going to change and the speed is going to change. Okay, so this is actually you have to note down. Okay, this input voltage will be fixed. Okay, however your output voltage and speed is going to change. I will try to change this icon itself. Okay, first we will give the input voltage, then output voltage, then corresponding speed. Okay, this will give better understanding. This is input voltage, output voltage and speed. If I change the duty ratio 0.1, okay, you can observe voltage is changed as well as speed is also changed. Okay, this is how practically it is going to work out. Here how much frequency you have maintained, you try to reduce the frequency. Okay, fine. If we increase the frequency, then it will stable quickly. 10,000 we will try to maintain. Okay, it is smooth only. Fine. This is your input voltage, this is your output voltage, and this is your speed. Okay, if I try to change the 0.5, okay, then you can observe this is your input voltage, this is your output voltage, and this is your speed. Okay, speed actually it will be in RPM. I have converted this RPM into sorry, radians per second into RPM. Okay, fine. This is about the experiment number 7.